Hi, and welcome to our miscellaneous topics. These are just our last three topics that we need to do. And the first one that we're going to talk about today is direct variation and inverse variation. And we're going to start out with direct variation. So what we have here, examine the graph at the right. The linear equation graph at the right shows that as the x value increases, so does the y value increase for the coordinates that lie on this line y equals 2. So, for instance, if x is 2, y is 4. If x is 6 multiplied by 3, then y is 12, which is also multiplied by 3. This is a graph of direct variation. If the value of x increases, then y increases as well. Both variable changes in the same manner. If x decreases, so does the value of y. We say that y varies directly as the value of x. A direct variation between two variables, y equals x, is a relationship that is expressed as y equals k times x, where the variable k is called the constant of proportionality. In most problems, the k value needs to be found using the first set of given data. So here we have an example that shows you how to find the constant of k, the constant of variation. The power p of a gear varies directly with the radius r of a gear. Find the constant of proportionality if p is equal to 300 and r is equal to 50. So it's telling us that p varies directly with the radius r, so that means p would be equal to some constant times r, and we just substitute in for p and r. So p is 300, r is 50, and to get k alone you divide by 50 and you get 6. And then we have a typical direct variation problem. In a factory, the profit P varies directly with the inventory I. If P is equal to 100 when I is equal to 20, find when P equals 50. There is more than one way to do this problem. This is one way to do the problem, and when you do it this method, you need to find the K value. But if you use the other method, which I prefer to use, for direct variation, I like to use proportion. X over y equals x over y. You just have to figure out what your x and your y are. In this case, we'll let p equal x, and we'll let I equal y. And you'll see we'll end up with 250. So when x is, or when x or p here is 100, when I is 20, so we would do 100 divided by 20 equals x is p, which is what we're looking for, and I is y, which is 50. So now I just have a proportion that I need to solve. So I cross multiply. 100 times 50 is 5,000 equals 20x. Divide by 20, and x is equal to 250. Personally, I think that method is a little bit easier than the one that they show you, but I wanted you to see that there are two methods. So you can set up your formula, find your constant of proportionality, and then substitute back in and find what you're missing. The other kind of variation we have is inverse variation. And that means the opposite of direct variation. And in an inverse, the values of the two variables change in opposite manner. As one increases, the other decreases. For instance, a biker traveling at 8 miles per hour can cover 8 miles in 1 hour. If the biker's speed decreases to 4 miles per hour, it will take the biker 2 hours, an increase of 1 hour, to cover the same distance. So inverse variation, when one variable increases, the other variable decreases. So, what do we got here? Notice the shape of the graph of the inverse variation is. If the x If the value of x is increased, then y decreases. If x decreases, then y increases. We say that y varies inversely as the value of x, and an inverse variation between variables x and y is a relationship that is expressed as y equals k divided by x, where it's direct, it was k times x, here it's divided by. And k is still the constant of proportionality. That has not changed. As with direct variation problems, the k value needs to be found using the first set of data. So this is the information you have. The number of hours h it takes for a block of ice to melt varies inversely as the temperature T. It takes 2 hours for a square inch of ice to melt at 65 degrees. Find the constant proportionality. Well, h equals k over T, and then it was 2 hours, and the temperature was 65 degrees. So just kind of put this over a 1 and cross multiply, and you'll get k is equal to 130. Okay, a typical inverse problem is such. Let's see. In a formula, z varies inversely as p. If z is 200 and p is 4, find z when p is 10. You can go through the finding the constant and then using the equation, or you can do it the other way that I like to do the problems. And for inverse, it's kind of like the opposite, where with direct we set up two proportions. For inverse, instead of dividing, we're doing the inverse operation, which means we're multiplying. So x times y equals x times y. So in this case, we're going to let x be equal to our z values, and we're going to let y be equal to the p values. So if x is 200, y is 4. We're trying to find x when p, or in this case y, is 10. So we have 800 equals 10x. Divide both sides by 10. So x is equal to 8. We found the same answer just using a different method, and I think it's a shorter method. Unless you're asked to find the constant proportionality, you can always stick to this method. And then there's just one more little formula here for you, or one more problem. In kickboxing, it is found that the force F needed to break a board varies inversely with the length of the board. If it takes 5 pounds of pressure to break a board 2 feet long, how many pounds of pressure will it take to break a board that is 6 feet long? Okay, so we're going to let x be the force, we'll let y be the length. So we're going to have x times y equals x times y. So if it takes 5 pounds of pressure to break a board that's 2 feet long, how long does it take, how many pounds of pressure will it take x to break a board that's 6 feet long? Well, becomes 5 times 2 is 10 equals 6x. Divide both sides by 6. We get a fraction, we just reduce it, which is 5/3, which is 1 and 2/3, just like that. Okay? And that would be pounds. That's really all there is with direct variation. Just remember, direct variation is x over y equals x over y. And inverse variation would be the inverse operation. Instead of dividing, you're multiplying. X times y equals x times y. And that's really all there is to it. I will see you in class.